we're going to really focus on quadratic functions here. When we talk about quadratic functions, we're talking about things that can be written in the form ax squared plus bx plus c. So in this case, a can't be 0, because if a is 0, then 0 times anything is 0, which means we just have a linear function. So that's why that restriction's there. Now, when we talk about quadratics, the domain for quadratics is going to be all real numbers, but the range will not be, because quadratics are either going to open up or they're going to open down. Just depends on really what the value of a is, if it's positive or negative. Now, anytime we talk about a quadratic, we can always talk about the vertex and the axis of symmetry. The vertex is the turning point, so it's where it changes from decreasing to increasing or increasing to decreasing. It's always going to be that maximum and that minimum value. The axis of symmetry is the line that cuts this graph in half, and it's always going to be x equals something, so it's always going to be a vertical line. So if we want to find the vertex and it's written in this form, we can find the x-coordinate by using negative b over 2a. And to find the y-coordinate, we're just going to plug this number back into the function, whatever that number is. So let's look at an example. Let's say we have y equals x squared plus 4x plus 1. So this guy's a quadratic. We know it's a quadratic because we see that x squared. If we want to find the vertex, it's going to be at negative b over 2a. Now our b value is 4. Our a value is 1. A is the number in front of the x squared. So negative 4 divided by negative 2. Negative 4 divided by positive 2 would be a negative 2. So our x-coordinate would be a negative 2. To find the y-coordinate, we're going to plug negative 2 back into that function. So we're going to get 4 minus 8 plus 1. So that's negative 4 plus 1, which is negative 3. So our vertex is the point negative 2, negative 3. Now, we also know because a is positive, this is going to open up. Okay, so if a is greater than 0, it's going to open up. If a is less than 0, so it's a negative, it's going to open down. So then we know really a rough estimate of what this graph looks like. We have a vertex at negative 2, negative 3. We know it opens up. It's got to look something like that. Now that's a very rough sketch, but you can kind of see what's going on there. We can also talk about that axis of symmetry. That's the line that cuts that graph in half, and it has to go through that vertex. So it's going to go through that vertex, negative 2, negative 3. So it's going to be that equation x equals negative 2. Now, if it's written in this form, it's going to be, that's called vertex form. So vertex form is nice because we can identify the vertex really easily. And it's just going to be a HK. Now, notice H is a number that's after the negative. So let's look at an example of those. Let's say we have y is equal to 3. Let's do a negative 3 times x plus 2 squared minus 1. So we have to see this like this. We need to change that plus 2 to a minus negative 2. So our h value is negative 2. Our k value is negative 1. So then our vertex is at the point -2, -1. And we know this guy is going to open down because that a value is a negative number. We also know about the axis of symmetry. It has to run through that vertex. It will be the equation x equals -2. Now you've got two ways to find the vertex for these. If it's in this form, I would completely use that. But if it's not, and it's written this way, then you could always complete the square. So let's go back to this first one. Now I'm going to write this. I'm actually going to write it on the next page. So we have x squared plus 4x plus 1. So if we wanted to complete the square on this, to complete the square, you have to have a 1 as a leading coefficient, so we're good there. We're going to take half that middle term and square it. So half of 4 is 2. 2 squared is 4. So I'm going to add 4 and I'm going to subtract 4. And the reason I do that is because here, 4 minus 4 is 0, so we have not changed the problem at all. But this allows us to factor this. That factors into x plus 2 times x plus 2, which is really x plus 2 squared. And then we can simplify this. So now this is written in vertex form, so we can see where the vertex is. Our vertex, remember, we have to view this as x minus -2. So our vertex is at -2, -3. Which is the same thing we got when we used that negative b over 2a stuff. I want to do another example with completing the square. Let's say we have y is equal to 2x squared plus 8x minus 1. So this one's a little bit different. Let's say we want to find the vertex. Before we start the process, we have to pull a 2 out here. So notice I'm just pulling it out, those first two terms. And now we're in a place where we can complete the square. So we're going to take half that middle and square it. Half of 4 is 2. 2 squared is 4. So I'm going to put that 4 in here. But if I add something in here, I got to do something out here too. However, you got to be careful. This 4 is actually multiplied by 2. So I'm really adding 8. And to compensate for adding 8, I have to subtract 8. Now this guy's going to factor. And this is the same thing as a -9. So our vertex is at -2, -9. Now let's go through and analyze this. Let's do a little bit more of this. We have an axis of symmetry. X equals -2. We know which way this opens. It opens up because we have a positive a. All of that is enough information to put on a graph, and then we could talk about increasing, decreasing. So we're at -2, -9. And we know it opens up. So it looks something like that. That's not a very pretty graph, but you get the idea of what's going on here. So we could talk about increasing. It increases from that vertex up. So -2 to infinity. It decreases from -infinity to -2. So we can fully analyze these. So now we need to move on to talk about x-intercepts. When we talk about x-intercepts, to find an x-intercept, you always set an equation equal to 0 and solve it. So Sometimes these are going to factor, and sometimes you got to use the quadratic formula. So just to remind you, the quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a. You could probably find a YouTube video that has put the quadratic formula to its song just to make it a little bit interesting, because why not? So that's assuming that you've got it written in that form. The discriminant is the stuff under the radical. So that's what we're talking about here. If you know the discriminant, then you know something about the x-intercepts. If what's under that radical is a positive number, then you're guaranteed 2 x-intercepts, and they're going to be distinct, which means you're going to get 2 different numbers. If that discriminant is 0, then you're only going to get 1 x-intercept, and it's going to touch the x-axis at the vertex. And then if the discriminant is negative, so now we're taking the square root of a negative number, and that means that we have something called a complex x-intercept, and we're not quite there. We're going to talk about complex numbers later, but for now we're going to say there's no x-intercepts. And I'm going to change that just a little bit. There are no real x-intercepts. And because there are no x-intercepts, and this guy's never going to cross that x-axis. In fact, it's not even going to touch the x-axis. So let's look at a couple of examples. We are going to fully analyze a couple of quadratics. So I'm going to start with that first one. We have f of x is equal to x squared plus 2x plus 1. Let's start by finding the vertex. So I'm going to use the x equals negative b over 2a. So this is negative 2 over 2 times 1. So negative 2 divided by negative 2 is 1. Oh, just kidding. Negative 2 divided by a positive 2 is 1. Be careful of signs. To find the y value, we're going to plug one in. So 1 plus 2 plus 1 is 4. So our vertex is at negative 1, 4. So I'm going to box that in. Let's find axis of symmetry. So the axis of symmetry is x equals negative 1. Let's find x-intercepts. To find an x-intercept, we're going to set this equal to 0. This is going to factor into x plus 1 times x plus 1. Oops. So if we set x plus 1 equal to 0, we're going to get negative 1. Notice we only had one distinct x-intercept. That would mean that discriminant was 0 if we're thinking about that quadratic formula. So if we were to plug everything into that quadratic formula, we would get a 0 for that piece. Kind of cool information to know. Y-intercept. If we were to plug a 0 in for x, we're going to get 1. So let's kind of sketch a graph of what's going on here. We have enough information. We have a vertex at negative 1, 4. We have an x-intercept at negative 1. So there is something going on. Let's go back and analyze this. We have an x-intercept at -1. We have a y-intercept at 1. This vertex, there's something just not right here. And it happened here. It's a sign error. So be careful about your signs. This should be a -1. So 1 minus 2 plus 1 gives us a 0 there. So our vertex is at 1, 0. So you always have to be careful there. Now, how did I know there was a mistake? We had an x-intercept at -1, but I said that the vertex was at -1, 4. Well, that wouldn't even form a function because that would fail that vertical line test. So it's always good to kind of think through and rationalize things to make sure that there's nothing wrong. So we have the vertex, we have x-intercept, we have y-intercept. We also know the axis of symmetry is at x equals -1. So I'm going to go ahead and draw that axis of symmetry in. So that's all we have so far. But we do have enough to create the graph. We know the axis of symmetry cuts everything in half. So that means that another point that's on this graph would be right here because it has to mirror this point over here on the right. So then our graph would look something like this. Now we know this guy is going to open up. And that has to do with the fact that our A is positive. So now let's go through and let's analyze domain and range and all that stuff. Domain for a quadratic is always all real numbers. The range, smallest y value is 0, and this guy's going to go to infinity. It's increasing from 0 to infinity, which is that right-hand side. It's decreasing from -infinity to 0. So we have fully analyzed that quadratic. Now let's look at that second one. So we have y equals -2x squared plus 2x minus 3 there. So we're going to go through that same kind of process. Let's start by finding the vertex. So we're going to use x equals -b over 2a. So that's going to be -2 over 2 times -2. And we're going to be careful with the signs. So we're going to get 1/2 out. The y value I got -2.5 for that one. So then our vertex is at 1/2 -2.5. Now, just for fun, I do want to go through completing the square on this one so you can see that again. So let's say we wanted to complete the square. Our first step would be to pull that -2 out of the first two terms. And that's going to leave us with a -1 there. So we're going to take half the middle and square it. Half of -1 is -1/2. And if I square -1/2, I'm going to get +1/4. But, think about what we really added. 2 times 1/4 is -2. That's really a -1/2 that we added. So we have to compensate with adding 1/2 here and here. This guy's going to factor into x minus 1/2 times x minus 1/2. If we were to FOIL out, we'd get that. And this is minus 2.5 here. So there's our vertex form. So we can see that the x-coordinate would be 1/2 and the y-coordinate would be -2.5 or -5/2. So we have the vertex. We know this guy is going to open down. And that's because we have a negative a value. Let's find x-intercepts. To find an x-intercept, we're going to set y equal to 0 and solve. So this is one I believe we're going to have to use quadratic formula on. So it's negative b plus or minus the square root b squared minus 4 times a times c all over 2a. So we have 4 plus, that's going to be 8 times -3 over -4. I'm using order of operations. So -2 plus or minus 4 minus 24 is a -20. So check this guy out. We have a negative under that square root. Remember, this is the discriminant. So that means that we have no real x-intercepts here. But we will have a y-intercept. If we set y equal to 0, then we would have 0 plus 0 minus 3. So we're going to get a -3 for that y-intercept. Axis of symmetry, I'm going to write that over here on the left. The axis of symmetry is going to be x equals 1/2. It's going to cut this graph in half. So let's see what we have. We have a y-intercept at -3. We know it opens down. And we have a vertex at 1/2 -2.5. Axis of symmetry has to run through the vertex. So if this y-intercept's on the graph, then a point here would mirror that. And it opens down, it's going to look like that. So we can talk domain. Domain is all real numbers. I'm going to abbreviate that way. If we talk about range, we're heading to -infinity, but our biggest y value is -2.5. Notice we're using a bracket on that range. We are increasing on that left-hand side, so -infinity up to -1/2, and we are decreasing from -1/2. That should be a +1/2. Everything's sloppy. +1/2. Going back over here. Let's try that again. So y equals -3. Vertex at 1/2 -2.5 here. Axis of symmetry. Sorry about that, guys. We have to mirror this point. We know it opens down. There she is. Domain is still all real numbers. The range is still from -infinity to -2.5. We are increasing on this left-hand side. So from -infinity to 1/2. We are decreasing from 1/2 to infinity. So there's our full analyzing of that quadratic.